Geometry lesson 6-2. We've started talking about polygons, and today we're going to talk specifically about one type of polygon, and that polygon is known as a parallelogram. And a parallelogram, in order for it to be a parallelogram, it has to have four sides, so it's a quadrilateral, and you got to have two sets of parallel sides to it. So both sides will be parallel. In a parallelogram, these two sides are parallel, and these two sides are parallel. And they can be tilted in any way they want, but that's what has to be the case. Now what's interesting is the fact that if you have a parallelogram, there's some other truisms that result from that. So here's what I want you to think about. From here on, the theorems that we look at are all based on the fact that we know that we have a quadrilateral that is a parallelogram. In other words, we have a four-sided figure that is a parallelogram. And if you know you have that, if you have been told or it's been stated you have a parallelogram, then you will know that the opposite sides are going to be congruent. So if I label this A, C, alright, that means AC is the same as B to D. According to what it says, AC, this side here, will be the same length as this side here. And AB will be the same length there. If I know I have a quadrilateral that's a parallelogram, if I've been told I have a parallelogram, then the opposite sides will always be congruent to each other. That's a fact. That's a theorem that I can use to determine lengths I might be missing. I also will know that the opposite angles will be congruent to each other. So that means that A and D will be the same, and C and B will be the same. So these two angles are going to be identical to each other, and these two angles will be congruent to each other. Opposite angles will always be congruent if you know you have a quadrilateral that is a parallelogram. All right? We also know that the consecutive angles are supplementary. Now, if I label it again, I'm still dealing with the fact that A and C are going to make 180 degrees. So A, C, B, D. What we're stating here is that A and C, those are consecutive. If you add those together, they'll always make 180 degrees. And A and B added together will make 180 degrees. We also know that D and C added together will make 180 degrees. And B and D added together will make 180 degrees. So these are three facts based on the fact that you know you have a parallelogram you can base it on. So if you knew that A was 100 degrees, that would tell you that C has to be 80 because they have to combine to make 180. And also you know that B has to be 180 or has to be 80 because they have to add to make 180. And if you know that's 100 and that's 80, C and B are supposed to be the same anyway, which means it has to be 80 again. And if that's 100, that's 100, so 100 plus 80. So it all starts to combine and connect. The last thing we know to be true is that they will bisect each other. So here's A, and here's B, C. Here's B, and here's D, let's say. Now the lengths of the lines don't have to be the same. This diagonal may or may not be the same length, but I do know that if that's 2, that's 2, because this line is bisecting it. It's cutting it in half. And if this line's 4, this line's going to be 4, because that line is being bisected in half by AC. Whichever way it happens, they will always bisect each other. So these are four facts that we know to be true for all parallelograms. And using those informations, we can then apply them to our shapes, and we can come to conclusions on values of angles and values of sides.